Hi, my name is Sanay Chaparala, and today I'm going to be teaching isosceles triangle proofs. So, let's say we have a triangle, and two sides are congruent. This type of triangle is called an isosceles triangle, and it is when a triangle has two congruent sides. So, some terms to know. So, first we're going to explore the anatomy of the isosceles triangle. And my bad for spelling isosceles wrong. That was a typo. So first, we're going to go over these basic terms with annotations. First, we have the legs, which are the two congruent sides of the isosceles triangle. We have one here and here. The base, which is the one side that isn't one of the two legs. And the base in this image is here. The base angles, which are the angles where the leg and the bases meet, and there's two. And finally, the vertex angle, which is the one angle where the two legs meet, and it's usually here. So, moving on, we're now going to explore more terms that are important to know. First, we're going to start off with an angle bisector. Basically, if say we have an isosceles triangle, and there's a line that splits it in half. The line that splits it in half is called an angle bisector, which is a line, ray, or segment that divides an angle into two congruent sides. So now let's go on to the next term, congruent, which I'm going to do in green. It's perpendicular, which means say you have two lines. If they cross exactly perpendicularly, it means they form a right angle. And this is a symbol for it. It looks like an upside down T. So if we have one triangle, there's an angle bisector going through it. Let's label it A, B, C. We can say that, and this midpoint M, we can say that AM is perpendicular to CB. So next we're going to explore midpoint, which I'm going to be doing in a blue color. Okay, so a midpoint is basically the middle of any given context. So say we have a triangle, an isosceles triangle, a bisector going through it. We can say that we can label this point M. M is the midpoint. Finally, we have a theorem, which is basically anything that is proven to be true. So say we have, let's do an example now. I'm going to do it in purple. So basically, say the Pythagorean theorem, where a squared plus b squared is equal to c squared. That's an example of a theorem because we know that if a squared plus b squared is equal to c squared, the triangle is a right triangle, and that we can find the hypotenuse and the other sides. Say this would be C A B. Okay, so moving on. Now we have the reflexive property of congruence, where any geometric figure is congruent to itself. So in these examples, we have BD is equal to BD, is congruent to BD, where this is line BD, which is shared between two shapes. So the side is congruent to itself, but it's part of two shapes. So next we have an angle can also be congruent to itself with the reason of reflexive property. So an angle can be shared by two triangles, which makes it congruent to itself. So in this case, angle ACE and angle ECA are congruent. Moving on, we have CPCTC, which is a mouthful, but basically what it means is if true triangles are proven congruent, the other parts, sides, and angles of the triangles are also congruent. So in this example, we're given that TV is equal to WV and UV is equal to VX through the definition of a perpendicular bisector. V is equal to Vx. Vertical angles are congruent right here. Vertical angles is basically when you have an X and the two angles inside the X are congruent. And now we can prove it by SAS, which we'll be going for the next slide, or side, angle side. And finally, we are asked to prove TU equals WX. And by CPCTC, we can prove which, because we proved the triangle congruence postulate, we can also prove by CPCTC, or congruent parts of congruent triangles are congruent. So now we know these are congruent. Moving on, we're going to go over the triangle congruence postulates. So if two triangles are exactly the same size and shape, they are congruent, meaning that they can have the common congruence postulates, which include, let's share a model here, SSS, SAS, ASA, AAS, and HL. Basically, these four are basically where a side, S equals side, and A equals angle. Basically, SSS, SAS, ASA, and AAS are proven when a set of angles, sides, or are laid out through reason, and you get that they prove the congruence of a triangle. HL is a little different. It means hypotenuse leg theorem. Basically, it means that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, say this is hypotenuse, this is leg in this case, it's congruent to this one, both triangles are congruent. So basically for these ones, if corresponding sides and angles show congruence, both triangles are congruent, and this one is a little different. So moving on, we have the isosceles triangle theorems. The first statement says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent too. So for example, let's label this A, B, C. Say A, B, and AC are congruent, then automatically the isosceles triangle theorem says that angle C and angle B are congruent. So going on to now that we've figured out that one, we can go on to this one, where it's basically the opposite of the first statement. If two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So again, ABC, if angle B and angle C are congruent, then automatically AB and AC are congruent according to this triangle theorem. Now that we've figured out both of them, it's important to understand the triangle theorems because if you are given an isosceles triangle, you can figure out if the proofs based on these statements slash theorems. So next, we finally have an example. In this example, we're asked to prove line segment JL and JK are congruent. And we are given, let's write that out, we are given that JM is the angle bisector of angle J, and L and K are congruent. Angle L and K are congruent. So first of all, we know that angle, this is the first statement we're going to be making, angle LJM and KJM are congruent because of the, can you guess why? It's because of the definition of angle bisector, which we were given, which splits the angle exactly in half, making it congruent. Next, we know that JM is equal to JM because if you guessed it, because of the reflexive property. Next, we know that because we are given an angle, and side, we can prove it by angle A. We can prove that triangles JML and triangle JKM are congruent through AAS. Yeah. So basically, now that we've proven this, we can finally prove that line segment JL and JK are congruent because of CPCTC, which any line segment can be, an angle can be congruent after an a triangle congruence postulate is used. So now that we prove this, we know that this is correct. Okay. So thank you so much for listening, and I hope you found this video about isosceles triangle proofs informative and engaging. Please like and subscribe if you enjoyed the video. Thank you. Bye.